The Kuiper Belt is a deep frozen record of the early history of our solar system, according to astronomer Mike Brown, a renowned expert on this distant region. Stretching from 4.5 billion kilometers to 7.5 billion kilometers from the Sun, the Kuiper Belt forms the outermost edge of our solar system. NASA has recently uncovered surprising new details about this mysterious zone, indicating that the history of our solar system might differ from what we've long assumed. The latest findings suggest that strange objects, and even a previously unknown planet, could drastically reshape our understanding of the cosmos. Have we made a big mistake by neglecting this region for so long? The Kuiper Belt, an icy domain of rock and frozen gases, is much more massive and expansive than the asteroid belt between Mars and Jupiter. It contains 20 to 100 times more mass and spans up to 20 times the width of the asteroid belt. Despite its size, we have only scratched the surface of its astronomical treasures and peculiarities. Adding to the complexity of this region is the scattered disk, an extension beyond the regular Kuiper Belt boundaries, characterized by irregularly distributed celestial bodies. This zone reaches far beyond the outer edges of the solar system. Exploring the Kuiper Belt presents unique challenges due to its extreme distance from the Sun. The faint light that reaches these icy objects produces only a pale glow, making them difficult to study. This region is also unusually cold, a condition that preserves the primordial materials from which these bodies formed billions of years ago. These frozen remnants offer scientists a unique window into the early days of the solar system. Most Kuiper Belt objects have remained largely unchanged for billions of years, making this zone critical for understanding the solar system's origins. Not just a place of darkness and cold, the Kuiper Belt is a dynamic region home to dwarf planets such as Pluto, Eris, Haumea, and Makemake. These objects provide valuable insights into the chemical composition and physical conditions of the early solar nebula, from which our solar system was formed. In addition to these dwarf planets, the Kuiper Belt contains countless other objects, including comets and smaller icy bodies that could harbor organic compounds. These may hold clues to the chemistry of life and the formation of DNA on Earth. Only 2 probes have explored this remote area so far. Pioneer 10 flew by in 1983, though it didn't encounter any specific Kuiper Belt objects during its mission. In 2015, New Horizons made the first detailed investigation of Pluto and its moon Charon before venturing further into the Kuiper Belt. During this journey, it encountered Ultima Thule, now known as Arrokoth, a strange, misshapen object that defies some physical rules. These frozen time capsules offer researchers a chance to study relics from the earliest days of our solar system. The Kuiper Belt is home to asteroids and comets, relics from the time when the Sun was just being born in a rapidly rotating disk of dust. These objects have remained unchanged in some regions of the solar system, preserving evidence of the conditions that existed during the solar system's formation. Previous research has shown that asteroids and comets contain surprisingly high concentrations of minerals and organic substances, such as magnesium sulfates, iron, copper, and amino acids, the building blocks of life. These findings suggest that life may have been intended from the outset in the solar system, and that Earth may not be the only place where life could have emerged. Given the latest findings in astronomy and cosmology, scientists cannot rule out the possibility that there were fertile phases with life on other planets or moons. Some icy moons, such as Europa, may have liquid oceans beneath their surfaces, potentially harboring life. Mars may once have had a thick atmosphere and liquid water, and even Venus might have experienced a fertile phase. As we continue to explore these possibilities, ancient objects in the Kuiper Belt serve as crucial witnesses to the early history of the solar system. The Kuiper Belt is now known to be home to around 2,000 trans-Neptunian objects, with Pluto being the largest. Pluto's reclassification as a dwarf planet in 2006 was due to its resemblance to other objects in the Kuiper Belt. Discovered in 1930 by Clyde Tombaugh, Pluto remained the only known planet beyond Neptune until 2005, when new objects were observed in this remote zone. The exploration of the Kuiper Belt began in earnest in the 1990s, and it wasn't until later that its true size and complexity became apparent. Like the asteroid belt between Mars and Jupiter, the Kuiper Belt has prompted theories about the existence of additional planets. Some researchers believe there could be a ninth planet lurking beyond Neptune, a body larger than Earth but smaller than Neptune. This so-called Planet 9 remains elusive, but gravitational anomalies in the orbits of Kuiper Belt objects suggest that something massive could be influencing their paths. Research into this possible ninth planet continues, and its discovery could further revolutionize our understanding of the solar system. Invisible objects in the Kuiper Belt are often first detected through their gravitational influence on nearby celestial bodies. These gravitational anomalies are what led astronomer Gerard Kuiper to hypothesize the existence of the belt that now bears his name. Although telescopes today can extend their reach to the outer solar system, the faint light in this region still makes it difficult to explore. Surprisingly, it is often easier to study Alpha Centauri, the nearest star system, than objects in the Kuiper Belt. Beyond the Kuiper Belt lies the scattered disk, an enigmatic region that stretches even farther into the darkness of space. The scattered disk contains objects with highly eccentric orbits, likely influenced by the gravitational forces of Neptune and other gas giants. These objects may include comets that are periodically drawn toward the Sun, some of which become visible from Earth. One of the most famous comets, Hale-Bopp, likely originated from this region and made a spectacular appearance in 1997, visible to the naked eye for months. The scattered disk provides valuable information about the dynamic processes that shape the outer solar system. By studying the composition and orbits of objects in this region, scientists can glean insights into the movements of the planets and the early conditions of the solar system. It is believed that the solar system has not always looked as it does today, and that millions of years of gravitational interactions gradually stabilized the orbits of the planets and other celestial bodies. The early solar system was likely a much more chaotic place, with frequent collisions between asteroids, comets, and planets. Some researchers believe that comets, rich in ice and organic compounds, may have delivered water and the building blocks of life to Earth. However, the origin of life remains a mystery, and it's still unclear what sparked the emergence of bacteria and other living organisms. As research into the Kuiper Belt and scattered disk continues, we may yet uncover new clues about the origins of life in our solar system. The scattered disk, an extension of the Kuiper Belt, is one of the least explored and most distant regions of our solar system. This region begins at the outer edge of the Kuiper Belt and stretches millions of kilometers farther into space. The orbits of the objects in the scattered disk are highly eccentric and inclined, likely caused by gravitational interactions with Neptune and other massive planets. Some of these objects travel as far as 150 million kilometers away from the Sun during their orbits, making them some of the most distant celestial bodies known. These objects' extreme paths provide a window into the dynamic early conditions of the outer solar system. It's believed that the gravitational forces of the gas giants ejected many smaller objects from the inner solar system into these more distant orbits. Over time, these scattered bodies settled into their current positions, forming the scattered disk. Understanding this region is crucial for unraveling the complex gravitational history of the solar system, particularly how the planets came to their current locations. One of the most famous objects believed to have originated in the scattered disk is the comet Hale-Bopp, which made a spectacular appearance in 1997. This long-period comet, which takes around 2,500 years to orbit the Sun, has a highly eccentric orbit typical of objects from this distant region. Its rare and extended visit was a reminder of the vast and largely unexplored regions that lie beyond Neptune. The scattered disk may also serve as a reservoir for other comets, some of which periodically venture into the inner solar system. As these icy bodies make their way toward the Sun, they provide astronomers with rare opportunities to study the composition and history of material from the farthest reaches of the solar system. The study of comets like Hale-Bopp, with their mix of frozen gases and organic compounds, also raises important questions about the role these objects may have played in delivering water and the building blocks of life to Earth. Thank you for joining us on this cosmic journey. If you enjoyed this video, please like, subscribe, and share your thoughts in the comments below. Stay curious, and until next time, keep looking up at the stars.